Ken Forrester, Executive Director at Momenta. Welcome to our Digital Thread podcast, produced by, for, and about digital industry leaders. In this series of conversations, we capture insights from the best and brightest minds in digital industry. They're executives, entrepreneurs, advisors, and other thought leaders. What they have in common is, like our team at Momenta, they are deep industry operators. We hope you find these podcasts informative, and as always, we welcome your comments and suggestions. Good day and welcome to episode 161 of our Momenta Digital Thread podcast series. Today, I'm pleased to host Dr. Zhenzhong Su, CEO and co-founder of Fixposition, a Swiss startup providing precise positioning for autonomous things. Fixposition is Momenta's most recent investment from our digital industry fund. Zhenzhong received his PhD from ETH Zurich with research focus on precise GNSS and GPS positioning. While there, he won the European Space Agency's Space Innovation Prize in the European Satellite Navigation Competition. He's also recently been nominated as a digital shaper by Swiss magazine Balance. Zhenzhong, welcome to our Digital Thread podcast.
Thank you, Ken. First of all, I would like to thank you for having me here. It's really an honor for me to be featured in Momenta's Digital Thread. I watched quite some of them. It's really high quality, and it's really great to be, let's say, on the same stage with many of the great entrepreneurs, share their vision and industrial insights through this platform. And second, I also want to thank you and Momenta for the recent investment in Fixposition. It's super exciting to have Momenta and you joining our journey to provide the precise positioning everywhere. That's the mission we are on, and we'll continue purchasing.
Excellent. Thank you for those kind comments, and certainly welcome. You've earned your right among all of our other founders and key digital industry executives in terms of being on this Digital Thread podcast series. And we're very pleased to be an investor in you as well. So always, I like to start these talking about one's digital thread. In other words, the one or more thematic threads that define the digital industry journey. What would you consider to be your digital thread?
That's a good question. I checked a bit around and just to making sure my definition of digital thread is correct. So if the definition of digital thread is about creating a closed loop between digital and physical world that drive the Industry 4.5 transformation, then I believe I have sort of two digital threads. So the first one will be my decades in the academia focused on the science of geomatics. So geomatics is actually all about digitizing the world we are living using geospatial informations. Here, the world is defined as using a variety of technology to collect data from the ground, air, and space-based systems. So you have a ultra-precise local system such as the theodolite, high-resolution image solutions through drones, and global information which you can obtain from sensing and the navigation satellite. Then the next step is actually to process this data and make it usable. It simply has no value if it's not standardized and usable to anyone. So this geoinformation has a broad range of applications from everyday uses, such as car navigation to specific industrial like construction, climate change monitoring, logistics, transportation, and many more. So with that, then it comes to actually my second thread, which is what we do at a Fixposition. We provide precise global position that works everywhere, where we create enable technology. That is to say that we enabling applications that until now have been limited due to either inadequate solutions or solutions that are not accessible to mass market yet. So our technology allows you to measure, collect, and produce high precision digital positioning information, which is the key to mass deployment of autonomous robots and drones that will be able to operate in all environments. And beyond this, I also believe that along our journey, we will discover more ways in which our technology will create value to the world and contribute to the advancement towards higher level of digitization and automation.
Always love founders who really have followed their passion. And as I go back and look at your background as we were doing the due diligence on the company, one can count that you've been focused on this area of geophysics or geomatics for almost 2 decades, and you're a young guy, so that's
Yeah.
saying an awful lot. What attracted you to this space?
Yeah. So to be honest, I think at the beginning after my high school exams in China, when I had to fail in what subject I have to focus for my bachelor, I didn't know much about geomatics back then. So all I know was that I was very good at mathematics, physics, and I liked them. So I decided to take a subject in the nature science field and went to Wuhan University to study geophysics. And then a big part of that geophysics study was actually about a geomatics engineer back then. And still nowadays, Wuhan University is among the leaders in Asia in this field. Then later on, I got the chance to go to University of Stuttgart for my master studies, and also most important, doing my PhD research at ETH Zurich. It was then purely driven by my passion and a strong interest in positioning technology. So in particular, I was already pitching and imagining that how cool it would be to have develop an autonomous position and navigation system to enable larger scale of autonomous revolution and deploy many of those robots really in real autonomy in the world. So then actually during the study, the more I learned about this subject, it becomes more interest. I still remember the quote from my professor who made at the ETH Zurich. He was saying that Albert Einstein would love the geomatics and geodesy of today because it is all about time and space. So it is a very attractive discipline or subject by itself.
Yeah, I love that quote about Albert Einstein. Absolutely. I'd have to fully agree as well, time and space. In fact, one of the early companies that did some work in this was called Space-Time Analytics at the time. They long since have been sold, but interesting all this coming to bear. So given your almost 2 decades of experience there, tell me a little bit about really what you've seen in terms of trends during that time in geomatics.
Yeah, indeed. So one common trend I see both in the science and application field of geomatics is that the precision of the system we develop and also the level of autonomy in terms of data processing have advanced significantly. So this was mostly driven by the fast development of a new sensing technology, new space technology, computer vision, and artificial intelligence, and a slam of other advancement in computer science and hardware. So what I see from my ETH time in this field is that the new research topic has focused on like application of machine learning to enable high volume and automated geospatial data processing, such as large-scale crop classification from satellite image or automated 3D point cloud processing. And also there are studies on the impact and application of low Earth orbit satellite for positioning and for remote sensing purpose. And then in the application field, what is interesting is that geomatics evolves together with the digital transformation and autonomous driving micro trend. So digital twins, HD map, high precision position and navigation for autonomous driving. These are all good examples for application of geomatics science. So in my most familiar domain, which is the centimeter accurate GNSS position technology, RTK. So the full name is the real-time kinematic GNSS positioning algorithm, has actually existed for long. So before it was most used for geomonitoring of structural deformation, mass movement like landslide, surveying for cartograph usage, and mostly scientific research purpose. But however, nowadays you will find it's widely used by drones, robots, autonomous vehicles as an essential part of their autonomous navigation system. So the border between geomatics, computer vision, robotics, and other subjects are increasingly blurred as their technology becomes essentially complementary to one another, and you simply find them in each other.
Yeah, in some sense, they are all becoming fused together in the sensor fusion. So all of this has culminated in your co-founding of Fixposition in 2017. So what is your origin story? In other words, what problem did you set out to solve and for whom?
So it could trace back to my PhD research. So in my PhD project, we were developing a local centimeter accurate RTK GNSS positioning system and use it for rockfall and landslide monitoring purpose. So at the same period, in that time, it was the race of autonomous drones, robot, and self-driving cars was getting the whole world excited. So it didn't take long for me to realize that a strong demand for precise positioning, which is the RTK technology for autonomous driving car, are coming. So I started to work on the first centimeter accurate RTK GNS positioning prototype for autonomous drones and vehicles together with Tonya Gazelle. We won the prize from European Space Agency at the European Satellite Navigation Competition, which encouraged us to present the technology and business idea to ETH Zurich for its Pioneer Fellowship program. So it's sort of startup incubation program. In that program, we got the chance to talk a broader range of drone, robot, and autonomous cars, and even train companies. I still remember it was nearly 100 companies that we have engaged with. So the key learning, what we have learned from all these conversations is that what is really missing to enable large-scale autonomous navigation is not the precision itself, but much more the availability of precision and the precise positioning everywhere. So taking GNS as only an example, RTK GNS can reach centimeter accuracy in open field, but its accuracy will degrade to tens of meters between high buildings, or it will simply not work in the tunnels where high precision is actually most needed for autonomous navigation purpose. So since then, we know the GNS technology and the limitation. It wouldn't solve that pain point alone, so we were struggling until the exciting moment of talking to Lucas Meyer and Lawrence Meyer, who were in another Pioneer Fellowship teams working on computer vision for drone navigation and inspections. So we realized that by combining RTK GNS and computer vision, we could increase the availability of the precise positioning to where it wasn't possible before. So we quickly incorporated our company Fixposition and immediately entered the incubation program from ESA. So that's sort of the origin story of how Fixposition was founded.
That must have been an awfully fun meeting when you guys got together and did the aha moment. I imagine there's a hand sketch on a paper napkin that is somewhere hanging on the wall now because of that. But it was that fusion that really appealed to us in terms of investments. Many of our use cases in this digital industry space, autonomous vehicles that work outside and inside. So think a autonomous forklift going in and out of a warehouse loading trucks. In a case like that, that transition between internal and external has always been very difficult. As you say, it could be up to meters of error. And so when we heard about what you guys did and really got a chance to look at it, we thought, wow, it looks like you guys have really taken a step forward in solving that. What have been some of your key use cases and wins?
Currently, we are very focused on the agricultural, logistics, and industrial robot market, where we believe that on one side, autonomy will come sooner, and autonomy in this field will help solving the global challenges like food security, labor shortage, and the green energy transition. And on the other side, we also see that our technology are much more highly demanded in these sectors. So for example, our customers, Neolex, PX Moving, and Agilix provide autonomous robot platform as well as the end solution for very interesting and useful application like post delivery, food delivery, factory patrol, and inspections. So we also have a customer who integrate our system into their reading and seating robot. This demand absolute decimeter or even centimeter accuracy at all times. So recently, there was even a new discovery. We have found out that we have customers actually using our system to produce and develop their next generation of lawnmower robotics. So all this application has one common pattern that this robot operate in all sort of complicated environment where it is difficult to maintain high precision positioning for autonomous operation. As you just mentioned, it has to frequently go next to nearby the building or even go indoor and then outdoor transitions. And these are exactly where the places that our technology shines.
At the risk of going too deep in terms of the technology, I think it's important for people to understand the different types or approaches to position measurement that are out there. And what's beautiful is you guys have already captured several of these, but already have a roadmap to do many more to make it even more precise. So perhaps you can outline the different approaches to positioning. You mentioned RTK, GNSS, video, LiDAR, etc.
Sure, would love to do that. So GNS positioning uses the GNS receiver to measure the signal traveling time and convert it to distance between user receiver and the satellite. So with 4 or more GNS satellite with non-position and the measured distance, then one can estimate the position of the user receiver. The simplified description will be like trilateration. So if we forgot about the need to estimate actually the receiver clock arrow. And in real world, there are many arrows that like ionosphere delay, troposphere delay, satellite orbit arrows, satellite clock arrows, and others. We have actually to either model or estimate them in order to get good positioning accuracy. Then, particularly to RTK technology, it's a differential GNS technology where we use a double defense data processing approach to cancel most of the above mentioned errors, as they appear actually as a common errors between satellite and between two GNS receivers. And most important, that RTK uses carrier phase measurement, which are 100 times more accurate than the pseudo range measurement typically used in the standard GNS positioning. So by solving carrier phase ambiguities, one can get down to really at centimeter level precision. Then camera-based visual positioning technology works by processing the image taken by cameras and tracking the feature point for land or landmarks in the consecutive images. So there are two types of visual positioning technology. So the first one we call it visual odometry, where they measure the displacement of this feature point in the adjacent image frames and then compare them to the measure the relative change of the camera. So, and then the second technology is called SLAM, simultaneously localization and the mapping approach, where they first actually create a spatial map out of this image feature point, and which later on they actually use it to localize the camera position in that map by comparing the feature point saved in the map to those seen by the camera in real time. And then apart from visual SLAM, there are actually also LiDAR SLAM. Well, the difference is that instead of using image, you're using the LiDAR point cloud, which are measured by measuring the travel distance between the laser beam point sent out and the flight time when they reflect and bounce back from the objective. So LiDAR-based SLAM are much more precise, but also the cost of LiDAR is way higher than the visual SLAM. So that will be the few of the mainstream technology that you often see for positioning.
So I'm an active runner, and I've gone through several generations of Garmin watches to measure the distance of my runs. And I remember the first generation I bought, which had the watch and some little side module you had to wear. And I was living in New York City at the time. So imagine my disappointment when I tried to run through New York City and have it measure anything.
Yeah, I can imagine that. Yeah, there was actually a scientific report summarized with the standard GPS. The average accuracy of a GPS at the New York downtown is 50 meters. So you are constantly 50 meters wrong.
I would have been happy with 50 meters in terms of absolute position, but it would tell me that my normal 5K in the morning run was actually like 1.2. And I was like, wait a minute.
Yeah.
So there are several companies that combine sensor fusion techniques to improve positioning accuracy. What makes Fixposition's approach unique?
So yeah, the technology we are developing, we call it deep sensor fusion, just to differentiate from the rest. So there are two places we make ourselves unique. So first is the tight coupled sensor fusion algorithm we developed. Unlike others combines the output of the different sensors, we process the data from GNS, from camera, from initial measurement unit, and additional other sensors in the future, really at the raw measurement level through a global optimized estimation approach. And second part is that we feed this data with different characteristics into our machine learning pipeline to train and learn from the data itself to know in which scenarios we can trust which sensor more. So while this approach, we're able to take the best advantage of the fact that the error sources of these different sensors are independent or even exclusive to each other. For example, in between high buildings where GNS signals are blocked and reflecting from the surface of the building, generating so-called multipass to the GNS signal, GNS will fail heavily here, as you just gave the example of running in the New York downtown. So, however, it is at the same place where actually camera can capture high quality feature point from the building structures and performs very well. So we can use the good vision data to correct the wrong GNS positioning. And in other scenarios, the other way around. Another important difference we are making is that our deep sense fusion algorithm and software is able to run on relative high lightweight hardware platform due to its high computation efficiency. So this somehow broadened the targeting platforms that we can apply our technology to, from small drones to large robots. So it's all gonna be suitable for applying our technology.
You guys have done a very nice job of packaging your end hardware into a very small module. And I'd encourage listeners to go up to Fixposition, all one word, .com, and they can see an example of the hardware you provide. So it's a very nice package for somebody to bundle into their equipment. But plus, as you mentioned, you've got a cloud-based side of it as well. So definitely worthwhile to take a look. As a Swiss-based investor, we've also appreciated your founding of Fixposition in Zurich. How have you found the Swiss ecosystem for founding startups?
It was literally by word of mouth, I will have to say that. So in the third year of my PhD, I was just chatting with a friend, just met during the football game break. So his family name is Lee. So he told me about his ETH spin-off, JuryMath, which develops innovative surgery technology. Once he know what I was doing for my PhD research and what it could be used for, he immediately suggests me that I should form a startup to look into a broader range of applications. But back then, I had no clue how to found a startup in Zurich as a PhD coming from China. So he then shared all his experience and most importantly, shared me the great Swiss startup ecosystem like Venture Labs, ETH Pioneer Fellowship, Venture Kicks, ESA Business Incubation Center, and they all provide great support to startups from different aspects and at a different stage. And that was helping me a lot.
Yeah, there is certainly a really good ecosystem here, especially around deep tech, med tech, precision equipment. All things Switzerland is famous for beyond the chocolate, cheese, and chronometers most people think of CH being associated with. So it's been a real pleasure to work in this ecosystem, but we've also come to appreciate the fundamentals of Swiss companies are actually quite positive, partially because, Switzerland, the culture here is to underpromise and overdeliver. And so it's very difficult to get most Swiss founders to say more than they actually do. Of course, go to Tel Aviv and Silicon Valley and you see quite the opposite, right? So really good fundamentals here, but always the refinement is the ability to market and sell oneself as well. Well, given your entrepreneurial journey, what would you advise other startup founders?
I would say I'm still learning myself, but if I could share something to those who are thinking about to start, then the advice will be think big to find something you truly believe and can generate value. And also you have to truly enjoy doing it for many years, then you're ready to go.
Well, given again my calculations of nearly 2 decades of working in this space, I think this is truly from the heart that you're sharing this, because it sounds like this has been what geomatics have been for you. So in closing, final question I always like to ask is, where do you find your personal inspiration?
So Elon Musk is one of the person that I often find my inspiration. So what I like about him is that he dreams big and achieve big. And the way he achieves it is to break the big vision into small ones and get there step by step. I most like his first principle thinking, that he make innovation by solving problems at the root. So whenever I'm struggling, I'm looking at and thinking, sometimes putting me in his position to thinking how he could solve the problem. Of course, we are doing at the Fixposition is focusing on solving a rather smaller problem compared to what he's doing.
I like that. And Elon Musk certainly has been an example and inspiration for a lot of people. Perhaps you call your principal, how would Elon approach this?
Yeah, exactly.
Well, Zhenzhong, thank you for sharing this time and these insights with us today.
Thank you, Ken. It's my great pleasure.
So this has been Dr. Zhenzhong Su, CEO and co-founder of Fixposition, a company well-positioned, if I might say, to guide the future of autonomous things. Thank you for listening, and please join us next week for the next episode of our Digital Thread podcast series. Thank you, and have a great day. You've been listening to the Momenta Digital Thread podcast series. We hope you've enjoyed the discussion, and as always, we welcome your comments and suggestions. Please check our website at momenta.one for archived versions of podcasts, as well as resources to help with your digital industry journey. Thank you for listening.